This is Higher Maths, it's practice paper F, and we're looking at question 25 in the non-calculator paper. We've got 5 marks for this question. So in the triangle shown, the magnitude of P and Q are both equal to 2, okay? And the magnitude of R is equal to 2 root 3. Find P dot bracket P plus Q plus R, 5 marks. Okay, first thing I'm going to do here is I'm going to multiply that bracket out, okay? So what I should get here is P dot P plus P dot Q plus P dot R, okay? So that's just that bracket multiplied out. So what I'm looking here now for is the scalar product of all of these parts here. And again, if I forget how to do that, I can go into the formula list. And what I can see here is that A dot B is equal to the magnitude of A times the magnitude of B times the cosine of theta, which is the angle between the vectors. And I've got to be careful that the vectors have got to be pointing away from the vertex. So I've got to be pointing away from the corner of the angle that I'm interested in. Right, so let's just write this one out in full so far. So for P dot P, so that would be two vectors, the same. So I can just do P squared for that. Or what I'll do is I'll just write it out in full. So I'm going to go, that's 2 times the cosine of the angle that's in between, and the angle in between is 0 degrees. Okay, so that's for this first part here. What I'm then going to do is I'm going to add on to that P dot Q. So P and Q are pointing away from each other, so that's good. That can help me out by working that out. P and Q are both 2 magnitude, so what I'll go for is 2 times the cosine of the angle that's between them, which is the cosine of 2 pi over 3. And then for P dot R, so there's P going in that direction, R going in that direction. Now what I really need is I need to have the lines or the vectors pointing away. Okay, so that would be going down in that direction. This one will then go in that direction there. So if I draw these lines in, so that line there is going to be the vector P. This one here would be the vector R. And that's them now going away from that corner that's sitting down there. Okay, and what I need to know is I need to work out the size of that angle. What I'll do is I'll work out the size of the angle that's in here first of all. And remember, if P and Q are both the same size, that triangle there is going to be an isosceles triangle. So both angles at the bottom are going to be the same. Angles in the triangle add up to 180. So what I can do there is I can say that in here, that angle is going to be 180, or pi, minus 2 pi upon 3, which is 120. And then, because if I work that out, it tells me what I'm sharing between these two angles, I'll then just divide that by 2 to get my angle. So what that'll give me is pi upon 3 divided by 2, and that should give me pi upon 6. So I know in here that's pi upon 6. I can write this one in at pi upon 6 there, and I know across there that's now going to be pi upon 6. So I now know that angle as well. So for P dot R, what I can write down is I can write down P, which is 2, so that will be 2 times. Now R is 2 root 3, so what I'll do for that is just write down the 2 root 3, and that will be times the cosine of pi upon 6. Right, so I've got 3 separate calculations, and then I'll just gather them up towards the end. One that I have to do a bit more work on is this part that's here. Okay, the cosine 2 pi upon 3, because I don't know that from my table of exact values, but what I can do is I can work that out in some way. Right, so if I think about cosine 2 pi upon 3, or cosine 120, if I think about a CAS table, 120 degrees would be sitting in here somewhere. Okay, so that would be 120 degrees, or 2 pi upon 3, we go all the way around there. The acute angle that I've got here is just pi upon 3. Right, so if I'm looking at cosine of 2 pi upon 3, I know that cosine's negative in that quadrant, so it'll be negative cosine, and it's going to be looking at the acute angle that I've got in there. So it'll be minus 2 pi over 3. So finally, what I'd get out of that angle that I would be using would be minus cosine of pi upon 3. So I'm going to replace that with minus cosine pi upon 3. So that will be for this one here. Okay, so let's work this one through. So 4 times, that'll be 4 times 1, because the cosine of 0 is going to be 1, so that's going to be 4 times 1. That'll be plus, and that's going to be 4 times, and I'm just going to write in this line here just so that you can see that I'm putting it in. And what we've got here is we've got 4 root 3, and that'll be times, and we'll go for cosine pi upon 6. Cosine pi upon 6 will be root 3 upon 2. Or that would be the 30, wouldn't it? That's cosine 30. Right, so we've got 4 here, plus, and that's going to be 4 times, and that's going to be minus a half. Plus, and if we multiply this out, we're going to get 2 times root 3 times root 3. That will give me 2 times 3. Right, gathering up now, so that's going to be minus 2 plus the 6, finally coming out with an answer of 8. Okay, so that'll be the question complete. Let's look at the marking for this one here. So what we'll do is 1 mark for multiplying out the bracket that's here. I'll go for 1 mark for getting this part here from working out where the angle actually lies. So that'll be 2 marks. Let's see, let's go for 1 mark for getting, we'll get 1 mark for getting this angle that's here. So that'll be the angle that we're interested in that's here. So that's 1, 2, 3. The 4th mark we'll get for, let's go for, I'll just go for this overall line that's just above here. Okay, for that one. And finally, just 1 mark for getting the 8. So that should be 1, 2, 3, 4, 5 marks out of 5.